Hi, math students. Mrs. Lee here. Now, as I'm going through these 5.1 notes, I want to make sure that you are also taking notes on a blank sheet of paper or on OneNote and completing these as I walk you through the process. So today is 5.1, Graphing Proportional Relationships. The launch is wanting you to create a graph based off of this data. I decided that the data could represent the number of hours and how much money you would be earning from a certain job. So of course the hours go along the x-axis and total hours earned go up the y-axis. I completed my hours by 1, 2, 3, 4, 5, 6, 7, 8, etc. and the total amount earned by counting by fours as it showed you in the chart. So 4, 8, 12, 16, 18, 20, 24, 28, 32, etc. Don't forget to label both axes, x and y, hours for x, total hours earned for y. Now, this could represent, like I said, the number of hours you babysit and how much money you earn. So I graphed the point 0, 0 because if you start at 0, 0, obviously you can't make any money unless you babysit. Then over 1 up 4, over 2 up 8, over 3 up 12, etc. So this represents, again, the total amount earned possibly from babysitting. This is what's called a proportional relationship. All proportional relationships go through the origin or through 0, 0. Ta-da! Moving on to the next one. Example number 2. There's a short video, obviously, that you're not going to be watching, so just continue to follow along. A video game store has a frequent shopper promotion. You earn 4 points for every video game you buy. Woohoo! Draw a graph to model the situation. Then it goes on to tell you that you need 48 points for a free game. How many video games do you need to buy if you have enough points for a free game? So along the x-axis is games purchased, up the y-axis is points earned. Now remember, every y-coordinate should be 4 times the x-coordinate. So I made a little chart over here. You have x's are 0, 1, 2, 3, 4, etc. And y's are counting by fours because it takes 4 games in order to earn 1 free point. So I graphed the point 0, 0. Aha! Also a proportional relationship because it does start at the origin 0, 0. You don't earn any points unless you purchase a game. So you have 0, 0, 1, 4, 2, 8, 3, 12, 4, 16, etc. Now, this can continue on. Notice I did not connect the dots or draw a line because you cannot earn points in between. You can't say, oh, I'm going to purchase 2.5 games and earn points off of those. So those are specific to 0, 1, 2, 3, 4, etc. So again, I did not draw a line between these dots. Go back to the question though, you need 48 points for a free game. How many video games do you need to buy to have enough points for that free game? Well, I need to look for the 48 right here. Go across the y-axis on the 48, drop down, 12 games purchased. So you will need to purchase 12 games in order to earn 48 points. Going back up to number 3, and this is another got it. Your school is selling raffle tickets as a fundraiser. The raffle tickets are sold in groups of 4 for $3. So every $3 you get 4 tickets. Draw a graph to model the situation. So at the bottom along the x-axis, number of raffle tickets, up the y-axis, total cost, and of course a good title for the graph would be cost of raffle tickets. Again, here are your x and y coordinates, your x and y points, 0, 0. How about 4 tickets for $3, 8 tickets for $6, 12 tickets for $9. The x is increased by 4s, the y is increased by 3 because you get 4 tickets for $3. Now over here, the point 2821 is going to be something significant here in just a second. Jumped ahead of myself. So we're going to graph the point 0, 0, 4, 3, 8, 6, 12, 9 as I did right here on the graph. Would you looky there? It's another proportional relationship because it passes through the origin 0, 0. And I did not draw a straight line or connect the dots through these points because you only pay for every 4 tickets, so every $3. So I can't have in between spots here connected. It's every $3 that I get my point. So no line in between the dots. Moving on to number 4, the key concept. Proportional relationships can be shown using tables, graphs, and equations. So if you look at this, I highlighted each one. The table starts at 0, 0. Doesn't matter that x's are increasing by 1 and y's are increasing by 2, as long as there's some sort of pattern there. The point is that it goes through 0, 0, so it's a proportional relationship. A graph, just like I have been showing you, starts at 0, 0 and goes through the origin and then continues on. This is showing that every y coordinate is 2 times the x coordinate. Over here, it's showing you the same thing. So the constant of proportionality is 2 because every time you multiply the x coordinate by 2 in order to get the y coordinate. So the constant of proportionality is 2. It's also the rate of change. Wow, it's amazing how those two relate to one another. Same thing over here. The constant of proportionality is the same thing as your rate of change of your slope. It's your y change over your x change, just like on your topic 7 test. So 2 divided by 1 is 2. And the equation, the constant of proportionality, y equals mx, is actually how we're going to talk about our proportional relationships, where m, whatever's in front of the x, right there, that little guy right there, whatever's in front of the x is what's called the slope, or the rate of change, or the constant of proportionality. It's your change in y over your change in x. If y is by itself, then whatever number is in front of the x on the other side is the rate of change. So for instance, y is by itself equals something times x. That number in front of x is your slope or your y-intercept. And in proportional relationships, nothing gets added to the end. So I can't have like y equals 2x plus 3, y equals 2x minus 7. Nothing is added at the end if it's a true proportional relationship. So most important thing to remember, whatever's in front of the x right there is your constant of proportionality or your slope or your rate of change, however you want to refer to it. Now, the next thing that we're going to talk about is going through the part 2 example together. A salesperson earns a 10% commission on sales of energy efficient appliances. Draw a graph. Is it proportional? Is the amount of commission, the amount he makes off of sales, is it proportional to the amount of sales he makes? So, for instance, I just chose these random numbers to plug in because they're easy to work with. $100, $200, $300, $400. So if I earn 10% commission off of that, I take the cost and I multiply it by 0.10. Why 0.10, you ask? Because 10% equals 0.10 as a decimal. So when I take 100 times 0.10, it's 10. 200 times 0.10 is 20. 300 times 0.10 is 30, etc. So here are the points on the graph that I can get. Obviously, it starts at 0, 0 because I can't earn commission unless I sell something. So the points on the graph, 0, 0, 100, 10, 200, 20, etc. Across the x-axis is sales, up the y-axis is commission, and the title would be commissions earned. Starts at 0, 0, go over 100 up 10, over 200 up 20, over 300 up 30, etc. Finally, you get to connect the dots and make a line because you're not just earning commission off of every $100 that you're selling, you're actually earning commission off stuff in between. For instance, I can sell $10 of appliances, not that it's going to be that least expensive, but I can still earn commission off of each little bit I spend. So finally, I get to connect the dots to show that it's going to continue. It's not every $100 or every $200. So the line is there. Still proportional relationship. Why? Come on, you know the answer, because it goes through 0, 0. And the last example for the day is something about a drilling, I think. Yep. So a drill is going to make a well by tunneling down into the ground. Notice right off the bat, our line is going down. All the rest of them have been going up because the drill is tunneling into the ground. So it's showing depths below the ground normal level. That's why you have your negatives in there along the x-axis, or I'm sorry, the y-axis. So the position of a drill would be the title. Time or hours would be along the x-axis. It just looks weird because it's up top this time. Your y-axis is along the side, and this is the position of the drill. -10 feet, -20 feet, -30, etc. Notice it's every 10 meters for every 8 hours. So I went ahead and counted my hours by 8, 16, 24, 32, etc. The position of the drill, remember, every 8 hours it gets to go down another 10 meters. So -10, -20, -30, -40, etc. You should be able to tell me right off the bat it's going to go through 0, 0 because I can't drill into the ground if we're not drilling. You're not getting any depth unless you start drilling. So it goes through 0, 0, obviously, and then 8, -10, 16, -20, etc. Come over here and graph those points. You get to connect the dots again because the drill continues to tunnel down into the ground no matter how much time is passing. So even though it takes 10 meters for every 8 hours, so 8 hours worth of drilling, you finally get 10 meters, which isn't a lot, by the way, you're still, even if I only drill for 4 hours, somewhere in between here, I've still made a dent in this tunnel here, so I still get to put the lines through the dots. Again, though, it's proportional. Now that the notes are done, you should have a completed note sheet. I want you to log into Digits and complete your 5.1 homework. If you have any questions, feel free to ask the substitute. You can also send me an email if you need to, and you can also look in Digits under View and Example. I hope you guys are being really, really good today. I miss you. Hope all is going well. Hope you had a good weekend. We'll talk to you soon.